welcome Larry Ellison.
Good afternoon. This afternoon I'd like to talk about two things: database and infrastructure. You know, Oracle's been in this business now for a very, very long time. We've actually managed through 4 generations of technology. The first versions of Oracle came out on mini computers, predating, believe it or not, predating client server. Came out on mini computers from Digital Equipment Corporation and mainframes from IBM. Digital is no longer with us. But that's where we started. That was our beginning. And when a new technology came out, personal computers, applications were re-architected from running on mainframes and mini computers, and the next generation of applications ran with the data on server computers and the application on a desktop PC, and that was called client server. And we helped our customers migrate from mini computers and mainframes to PC networks or client server computing. We allowed them to preserve their existing investment in applications and data and move gracefully and enhance those applications for client server, taking advantage of the new technology. Then about the time of Oracle Release 8, actually known as 8i, we went through another generational change, where we helped our customers move from client server computing to internet computing, where both the application and the data was on an internet server, and you typically accessed that application and data through a web browser. And that was called internet computing. Once again, we preserved our customers' investments in applications and data, let them move to the next generation of computing, while preserving their investment and allowing them to exploit all of the cool new technologies that came along with internet computing. In other words, we preserved their investment, they migrated, and we helped them take advantage of internet computing. And here we are now going into our 4th generation of computing. In my career, which is now cloud computing, and once again, we're helping our customers migrate their existing applications and their existing data and move them to the cloud. And that migration is not going to happen overnight. There's going to be a very long period of coexistence. But we're not just making it easy to migrate. We're making it easy to migrate and then take advantage of the new generation of computing, cloud computing. I won't demonstrate, actually I do have a demonstration at the end of this presentation where I'm going to create an all-new virtual data center in the cloud. Compute and storage and a virtual network, do all of that stuff. But another demo I could have done today was, and last year I did, push a button, move all your data to the cloud. Now you can push a button and move your WebLogic cluster, all of your application infrastructure and application instances also to the cloud with a single button, and then add data guard, add high availability with the push of a button. Preserve your investment, make coexistence and migration easy, and allow you to enhance and improve your applications within the new architecture of cloud computing. That's what we have always done. Now, again, everyone knows the industry is shifting from on-premise to the cloud. Again, it's not going to be an overnight shift. There's been this long period of coexistence. But there are a lot of attractive things about the cloud. The ability to, when you have a project, and you decide to start a project, you don't have to buy a computer and have the computer delivered and put up in your data center anymore. You literally log on to the Oracle cloud or other vendors' clouds, get a compute instance, get storage, and get running right away. It provides incredible agility, ability to move quickly. If you need more capacity, either for development or for a running application, The capacity is available instantaneously on demand. And because cloud computing is very similar now to all the networks, the water network, the electricity network, we take all of that complexity in the network that's hidden from the consumer of the technology, and all of that capacity should be available at a much lower price because there are great economies of scale in cloud computing. It should be easier for us to build a large cloud, a large global cloud, than for 10,000 or 100,000 of our customers all to build their own data centers. There should be enormous advantages, economic advantages, in terms of the scale of doing cloud computing. Also, specialization of labor. We should be better at running our database than anyone else in the world. That's what we do for a living. You can see, as you spend time in this conference, that a lot of the development we've been doing over the last couple of years is really focused on the cloud. Oracle 12c, by the way, Oracle 8, which came out for the internet, was known as 8i, small I for the internet, Oracle 12, small c for the cloud. Oracle 12c Release 2 is really a cloud-centric release of our database. We have focused on cloud features. One of the most important cloud features we actually came out with 12c Release 1 was multi-tenancy. The ability to have pluggable databases into a single database container. And we had 256 pluggable databases in Release 1. And now we've scaled that. We've now scaled that to over 4,000 pluggable databases fit into a single container, letting you manage 4,000 databases as one, backing up 4,000 as one. It gives you great economies of scale. It should lower your costs and make your administration easier by using the multi-tenant option, which we've scaled up dramatically between Release 1 and Release 2. We've added SaaS application containers. We've enhanced the Oracle database with capabilities to allow you to build what's called a sharded database. Now, a sharded database is very different than RAC. RAC, where you have these database partitions where we're really keeping the memory synchronized for you automatically. These are really, if you will, a bunch of federated databases. You can have, a large RAC cluster might be 16 nodes, 32 nodes, a very large RAC cluster. A sharded database, you might have 1,000 nodes, all containing fragments of the same database, spread all over the world. It's a popular new technology for building global scale databases, and we've added the features to do that inside of Oracle Release 12.2. The in-memory capability is also greatly enhanced. So you can now have active data guard. You can have the column store in active data guard. You can have in-memory database and high availability working in concert to give you dramatically better performance. Oracle continues to innovate as we move from internet computing to cloud computing. So if a cloud database is in your future, and I think it is, so which cloud is best for database? Why do you think I'm asking that question? I have an opinion. The Oracle database, they want me to actually speak down here. I know this, is this better? Closer? I haven't tried this yet. Okay, the Oracle database is optimized for cloud computing. In other words, Oracle 12.2, we did a lot of work on 12.2, specifically implementing cloud features and cloud optimizations. Now, our high-end service, our extreme performance service, is our Exadata cloud service. And the Exadata Cloud Service has all of the options. All of the options are included in the Exadata Cloud Service. And the Exadata Cloud Service happens to be 100% compatible. By the way, audience, down here or up there, what's easier for you? Down? Down's better? Okay. Yeah, I feel like the Speaker of the House now. We'll have a voice vote. How many down? Let's hear it. Up. That wasn't very close. The downs have it, as someone would say. Okay, the Exadata Cloud Service is our best, our highest end cloud service, delivers extreme performance in the cloud, and it's 100% compatible with the Oracle software you run in your data center. Again, that makes it very easy for you to move that data from your data center into the cloud. And by the way, if you want to, you can move it back to on-prem, or you can move it to a different cloud. The Oracle database is truly portable. But it's very easy now, if you use the Oracle database, to continue running stuff on premise and move, let's say, test and development to the cloud. It's 100% compatible, the same software running in both places. You get all the benefits of the public cloud, and you preserve your investment over the last 20 or 30 years in data and applications. And now we have a third option. We have the Oracle software, running in your data center, or you can have the Exadata database machine running in your data center. So we have a couple of on-premise options. Just the Oracle software running on the hardware of your choice, the Oracle software running on an Exadata database machine that you bought and installed on premise. Now we're offering a third choice, which is the Exadata Cloud Machine. The Exadata Cloud Machine is literally the identical software and hardware that we run in our public cloud. So if you will, it's more than compatible, it's identical. That makes coexistence and migration absolutely as easy as possible. And if you decide not to buy an Exadata, instead to subscribe to the Exadata machine, cloud machine at customer, you pay the identical price that you'd pay if you bought it in the cloud. It just happens to be in your data center, behind your firewall, connected to your high-performance local area network. That means your network charges should be less, your network should be faster, and it should be a little bit safer because it's behind your firewall. And statutes may require you to stay out of public clouds anyway. So, yet another option for our customers to take advantage of cloud computing. The Amazon cloud is not optimized for running Oracle. Well, why do I say that? I mean, it's easy to say, that's fine, then what would you expect me to say? Okay, easy to say. I'm now about to show you a series of benchmarks, all of which are published on our website, all of which you can run yourself to verify that what I'm saying is accurate. Amazon can run them and disagree if they get different results. These benchmarks are designed to compare Oracle on the Oracle public cloud to the Oracle database on the Amazon cloud. So kind of an Oracle to Oracle comparison. Okay, I'm going to stick with Oracle, but I'm going to run it on the Amazon cloud rather than the Oracle cloud. Is that a good decision or not? We'll take a look. Or, the heck with Oracle. I'm going to get off Oracle. I'm going to go on this amazing new database from Amazon called Redshift, Amazon's premier analytic database. Is that a good idea? Well, we've got some numbers we'd like to show you. Or you could say for transaction processing, I'm going to get off Oracle and I can get onto that great new Amazon OLTP database called Aurora. And I'm going to run that in AWS. Is that a good idea? And then, of course, we're even going to look at Aurora running analytics and Redshift running OLTP, just in case you're saying, gee, I only want to run one database. And I got to pick one of these two Amazon databases. I just run Oracle for analytics, I run Oracle for OLTP. Can I pick either of these Amazon databases from both? And we have some numbers there that I think you'll find fascinating. Here's the first one. So if you run Oracle and the Oracle Public Cloud for analytics, again, this is Amazon's fastest configuration. This is as fast as we could make Amazon Cloud run Oracle. And our database team worked very, very hard at getting Amazon to run as fast as we could. Amazon is welcome to publish their own result. If they can beat our result, we'll put their result in. We don't think they can. This is Amazon's fastest server, fastest configuration, running analytics against Oracle 24 times, not 24%, 24 times slower. Now, that has a huge cost implication. Cost implication is what we do in 1 hour at Oracle, you do in 24 hours at Amazon, and it costs more to buy 24 hours of Amazon services than 1 hour of Oracle services. So these aren't just performance differences, these are also enormous cost differences. All of these benchmarks are real, they're all published, it's all reproducible by you or Amazon or anyone. Okay, what about OLTP? Running Oracle at Amazon or running Oracle in the Oracle Public Cloud? Here we're 8 times faster. This is as good as Amazon ever gets. 8 times faster. OLTP. Amazon Web Services are simply not optimized for the Oracle database. I'll go further than that. Amazon Web Services aren't optimized for their own databases either, as you will see. It doesn't get better, it gets worse. Amazon, who pioneered infrastructure as a service, is still delivering first generation infrastructure as a service. Their IOPS, the ability IOs per second, were almost 10 times better than just purely on infrastructure. Why? Why does Oracle Public Cloud run the Oracle database so much better than the Amazon Public Cloud? Well, on our infrastructure, if you look at this, our storage performance, our IOs per second are 8 times better than Amazon. Our IO bandwidth, the ability to transfer data off of storage and into a computer, is almost 20 times faster than Amazon. In the public cloud, these just nominal rates going back and forth. And Amazon has no scale out capability. In other words, you can't add, you get Amazon's largest node, you're done. They have nothing they have no support for real application clusters. So they can't scale out, they can't improve their performance by adding more servers. And by the way, when you have one and only one server, that one server is a single point of failure, and if it goes down, you are down, and you are down hard. Well, okay, that's first comparison, Oracle on the Oracle Public Cloud compared to Oracle on the Amazon Public Cloud. What about Amazon's own databases? Okay. Their best, their premier, their really hot, new analytic database is called Redshift. We're more than 100 times faster than Redshift using half as many CPUs. More than 100 times faster than Redshift. Again, these are not made up numbers. Juan Loaiza and Andy Mendelsohn just don't make up numbers. What is Redshift anyway? I mean, I've read a lot about it. It's from Amazon. Therefore, it's in the cloud. It must be really cool. Where did it come? What is it? Where did it come from? This Redshift thing. Redshift sounds cool. It's a new name. Well, it's a new name for an old product. Redshift is Postgres. It's a Postgres database, and it started as a fork. There was a company called Paracel that took a 2005 version of Postgres and forked it. And then they went out of business and Amazon bought the stuff, the assets out of whatever. They bought it. Okay, that's where it came from. It came from UC Berkeley, nothing wrong with UC Berkeley, Postgres open source project. He said, well, at least there's a big team of people working on it now. It came from Postgres, open source, communities working on it. No. Amazon forked Postgres, and it is now totally proprietary. They do not contribute anything back to the community. It is not an open source database. The only people who are working on Redshift is the team at Amazon. It is not open source. The only place Redshift runs, the only place on earth that Redshift runs is Amazon. You know, Oracle runs on premise, Oracle runs in the Amazon cloud, Oracle runs in the Oracle cloud, Oracle runs in the Microsoft cloud. Redshift, it's easy for me to remember all of the places it runs. Even at my age, I can remember a list of one. Only runs, not open source, closed, proprietary, only runs at AWS. So if you build an application on Redshift, well, you're going to run it forever on Amazon. You are locked in, baby. Okay. It is not an open source product. Okay, let's keep going. Why is it so? How can it be more than 100 times slower? That's not possible. That's ridiculous. Well, remember where it came from, a 2005 fork from the UC Berkeley project. 15 engineers worked on it between 2005 and 2011. And they're just missing a few things. I mean, I'm not going to read all of the stuff that they're missing, but all of these features, they got table level locking. We haven't had table level locking since version 5 30 years ago. But most of this, to be fair, they're not 30 years behind the time. To be fair, they're only 20 years for this feature list. And when I'm talking about Amazon, I'll be nothing but fair. You can count on that. This is all true. Again, this is all printed. If someone wants to say, this is not true, explain to me where it's not true, these are all facts, and if you want to refute them, take it one at a time and refute them. All true. Quite amazing. And we got a little picture of the cell phone people were using at the time of Redshift. So maybe, if you still got it, you should be programming on Redshift. Well, back to what your phone looks like. Okay, Aurora versus Oracle for transaction processing, 35 times slower than Oracle. Okay, where did Aurora come from? Well, Aurora is actually a fork from MySQL. By the way, MySQL is MySQL is open source. We are the primary developers and supporters of MySQL. We contribute back to the community. We offer MySQL in our cloud. And you say, well, that's great. I mean, Amazon's got their open source MySQL version, and Oracle's got its open source MySQL version. No, MySQL started as open source, but Amazon, when they forked it, they shut it. It's not open source. The only place you can run MySQL any place. You can just download it and run it on any computer you want. I mean, I can't list all the places you can run MySQL. Certainly going to run it in Amazon, IBM, and tons of different kinds of computers and operating systems, and all of that. But Aurora is so much simpler to list all the places you can run. Only runs on Amazon, is not open source. They contribute nothing back to the open source community. And it's 35 times slower. 35 times slower for OLTP than Oracle. How can that be? How can that be? Same problem. Same problem. About 20 years behind. If you look at this list of features, can't replicate encrypted databases, single thread replication, no real query optimizer, no support for parallel query. I can go on and on and on, but I'm just not going to read the list. But simple, just remember, if you want to go 35 times slower, you have to commit yourself 100% to Amazon, because once it's hard, you got to convert your application to Aurora, which is hard. But once you've done it, you can only run on Amazon. I'm not sure that many people will think that's a good idea. Okay, and just for the fun of it, we said Aurora, which really is Amazon's OLTP database, and Redshift is Amazon's analytics database. You know, all we have is one premier database, Oracle database. We use it for analytics, we use it for OLTP, we use it for object storage, we use it for all sorts of things. XML, you name it. It's our in-memory database. I mean, it's all of that. But what if you said, okay, I really want to just run one. I like the idea of just picking one database, running on one database. I've got Oracle, which should I go? Should I go to Redshift for OLTP and analytics, or I should go to Aurora for OLTP and analytics? Well, okay, if you try to run OLTP on Redshift, we had a hard time measuring it, but I can assure you, it's not 1,000 times slower than Oracle. It's thousands of times slower than Oracle. Thousands. We'll give you the queries, whatever you want to, we'll give you the transaction load. We have all the programs, it's all on our website, you can rerun them. Thousands, tens of thousands of times slower. You cannot use Redshift or OLTP, period. Analytics only, and not very good at that. Same thing with Aurora. You try to use Aurora for analytics, for query processing, it's thousands of times slower. Absolutely thousands of times slower. Okay. And this is, okay, performance isn't great, but thank God Amazon is open. It's open. Really? I've said it several times and I'll keep saying it. Amazon has 3 databases: Aurora for OLTP, Redshift for analytics, and DynamoDB, which is its NoSQL database. All 3 run only in AWS. No place else. If you want to use Aurora, why don't you use MySQL? MySQL is open source and much faster. And by the way, MySQL also runs in Amazon. Why you would run Aurora in it? Anyway. We run on-premise. We run in Amazon. We run in IBM. We run at Microsoft. We run every place. We give you lots of choices. We run on the hardware of your choice. We run on specialized machines like Exadata. We can put our public cloud behind your firewall, or you can use our public cloud. Lots and lots and lots of choices. People think that Amazon is open source. They say we have a lot of open source software, and they think Amazon and open source goes together. Just not so. We develop Linux. Our own version of Linux, open source, contribute back to the community. We develop MySQL, open source, contribute back to the community. They don't do that. AWS is more closed than an IBM mainframe. Now, someone would say, that's ridiculous. How can that be? Well, Back in the days of IBM mainframes, a company called Amdahl made an IBM clone. And a company called Fujitsu and a company called Hitachi made IBM clones. So if you could take your entire IBM mainframe workload, lift it up without changes, and run it on an Amdahl machine or a Fujitsu machine or a Hitachi machine. You had choices. There is no choice with Amazon. You run on Redshift, it only runs on Amazon. There is no choice whatsoever. Once you move in, you can't, at AWS, you cannot move out. If they raise prices, get out your checkbook. Go back again. And this is really hard to, and it's hard to slide. Go back one slide, please. I just want to look at that a little longer. I mean, if you were talking to somebody and you said that AWS was more closed than IBM mainframe, they'd look at you like you were nuts, or you were taking some kind of pharmaceutical and they want to get the name of that because they want to try it too. But it's just not the case. It's just true. With IBM, you had a couple of places you could go. Fujitsu, Hitachi, Amdahl. You had choices to run your workloads. Here, there are no choices. There's only one choice, and it's Amazon. It's amazing. And it's not what people think when they think about the Amazon cloud. Amazon's very easy to adopt, right? Well, if you want to use Aurora or you want to use Redshift, you're going to have to rewrite your applications and, defeature your applications and accept you're going to run a lot slower. So, there's nothing compatible about these things. There's nothing, it doesn't make your workloads portable. Our whole strategy over the years has been to make your data and workloads portable so you can migrate. So you have a lot of choices in the current generation of computing, and then when a new generation of computing comes along, you can migrate to that as well. So customers always have choices. Okay. There must be something good here. Got to be lower cost. Used to be, not anymore. Not anymore. The Exadata Express Cloud Service is our new entry-level version of the Oracle database in the cloud. It's priced very aggressively, $175 a month. You think, oh, well, this is the dumbed-down version of Oracle. This can't be full Oracle. No, this is full Oracle with all of the options running on the Exadata database machine with Exadata performance. It's absolutely ideal for development tests and departments. Very aggressively priced, very easy to get started. Press a button, you get started with Exadata Express. We think, again, this is good. Applause is fine. Thank you. So we think this is going to be a big hit with our customers. Again, it's only very, very cost effective. They're starting to move development and tests onto the Oracle Public Cloud with complete compatibility with what's in your data center already and complete compatibility with all of our different cloud services. Okay, so this is a comparison prices with Amazon. And you can see that the Exadata Express service is cheaper to acquire and has a lot more capabilities. It has the full Oracle capabilities, a lot more database than Aurora or Redshift, and completely compatible with what you're already running. Runs your existing applications, runs your existing databases. Okay. Amazon is the leader in cloud infrastructure, right? It used to be true. Used to be true. Maybe the most fun in this Oracle Open World is the announcement of Generation 2 of our infrastructure as a service. And with Generation 2 of our infrastructure as a service, we leapfrog Amazon in a lot of ways. Certainly in cost, lower cost, and certainly in performance, higher performance, but also in reliability and in security. In those four areas, our infrastructure as a service is demonstrably superior. Here's a simple slide I showed on Sunday. Again, for a lower price, for 20% less, if you're willing to spend 20% less, you get twice as many cores, twice as much memory, 4 times as much storage capacity, and more than 10 times the I/O capacity, I/Os per second. But you got to be willing to spend 20% less, or you just can't enter the order. The Oracle data centers are themselves fault tolerant. Let me be clear, this is something we call a region, and it really is 3 data centers that are relatively close together. I mean, even the speed of light is not instantaneous. So these 3 data centers are connected with a fiber optic ring, and if one of the data centers fail, you're fine. The other 2 data, we replicate the data across data centers very, very rapidly. So losing a single data center doesn't mean you lose your data or you lose your application. And here we have a very low latency network. One of the things that's quite different between our infrastructure and Amazon's infrastructure is the design of our network. And here the network has a high bandwidth, very, very low latency. We get this very, very low latency because of the flatness of our network. In fact, our network, and I'll show you in a couple slides down the road, the maximum distance between any 2 points in the network is 2 hops, and it's a very flat network. Again, and I'll show you in a second. We don't oversubscribe our network. In other words, we're not like an airline that has 120 seats, but we sell 160. So if all the people show up, 40 people have no place to go. That's an oversubscribed flight. Yes. 120 seats, 100. A lot of clouds operate with oversubscribed networks, where they have a lot more capacity than if everyone shows up for a few seconds, someone doesn't get a seat. Someone's data doesn't go through. You lose your performance. Here, the bandwidth is guaranteed in our network. So we have a guaranteed low latency, high bandwidth network between hosts inside of the availability zone and between availability zones within a region. And then we put these regions all over the world. We put them, put them in North America and connect them. And we put them in Europe and connect them. And the reason you want these regions all over the world is exactly what I said before. The speed of light is not instantaneous. If you're in London and accessing the server in Phoenix, it takes longer than if you're in London and accessing a server in Scotland. So it's very important to keep the data and the data centers close to the users. And we do that by building these regions all over the world. Another thing, again, it's very, very important, is the way the network works. We have a control plane that runs the network, where the virtualization is really off-box. So the network and storage virtualization is not software that runs on the server. If you will, it is software that runs on our special network interface adapter card. It makes it very hard for someone to sneak into our network and take control of it, because our control plane is not accessible in the public internet. So it's isolated. Sometimes people call this
Okay.
the only way the public internet gets attached to this network is through an explicit virtual connection. This public internet which we can manage, we can audit, we can control. We can control.
I think this is... Oh, it's a session?
Google.
You're preserving your existing investment, allowing you to move it to the cloud. You want me faster, more secure, more reliable than you can in your own data center. This is a big deal.
I'm like
big difference. You simply cannot do this with Amazon. Moving applications and data into Amazon is a lot of work. In this case, you move your existing data, your existing applications, your existing network with its existing IP addresses intact, and you move it over into the cloud. And you're saying, oh, that must be really hard. That must be really hard. Of course, we run Docker containers, and the virtualization is at zero overhead. And by the way, you don't have to bring your own hypervisor. We don't insist you bring your own hypervisor. We don't insist you bring your own hypervisor. We're very compatible with enterprise Linux. We think it's the highest reliability, highest performance Linux around. We have our own hypervisor based on Zen. By the way, our Linux is open source and we contribute to the community, and our hypervisor is open source and we contribute to the community. And we offer those. Here, you can run all of that again with a push of a button, move your data, move your applications. Use our hypervisor, use our Linux OS, reconfigure your network, and you're up and running. And you say, well, that's got to be really hard. Come on. I mean, this lift and shift thing. How? I mean, I'm going to have some, teams of people working a very, very long time. I would say, to define a new data center in our cloud. I don't mean a new data center. I mean creating a new network. I mean creating a new subnet. I mean locating it at a specific availability zone. Adding storage. Adding compute capacity and memory. That's got to be a really hard job. Well, let's see. I'm going to try to do it before I run out of time. So this is the last thing I'm going to do. It's the demonstration of creating an all-new data center. An all-new data center in the public cloud. Network, subnet, storage, compute, everything. So I got someone else's water here. I'm tempted to drink any new water. When you're no longer CEO, this is the size of water you get. I want to see what size water Mark and Safra got when they were up there. We're looking to save money every place we can. This is ridiculous. All right. I'm going to have to put my glasses on. All right, in addition to my other duties as Chief Technology Officer, I am also in charge of the account. Oh, wrong thing. This is not a mouse. That's my clicker. Okay. I'm now in charge of setting up accounts and setting up virtual data centers in the Oracle Public Cloud for some of our customers. They've got me doing that too. This is the board's idea that all right, so I'm going to sign in. I'm going to do everything but the typing here. I'm going to show you every single click. I'm not going to do all the typing myself. I think that would be a little bit tedious and probably take a little too long. But you'll see every single screen, every single click. Now, when you buy services in the Oracle Public Cloud, you set up an account. Let's say in this case, your company NextGen. But if NextGen buys the pool of services, they might want to parcel it out. I mean, NextGen might be a medium-sized company, and they have a United States operation, they have a Latin American operation. They might have, they might want to build those things separately. This might be separate IT organizations, and they're going to set up virtual data centers for the different IT organizations. But NextGen purchases centrally, then is allowed to distribute the cloud resources to the different sub-organizations inside of their organization. So I'm the NextGen account administrator, and I've got a US sub-account, I've got a Latin American sub-account. I'm going to create a new sub-account in the UK. I'm going to grant Robbie Bechtel privileges on this account. He'll become the sub-account administrator. I'm going to give him 100 Oracle CPUs, 2 terabytes of block storage, and 7 terabytes of object storage. And I'll create the sub-account. Okay, it's right on top. We've got the new sub-account. And now I'm going to create a compartment. A compartment is kind of a group of people that are associated with cloud resources. It's a group of people that are authorized to use the network I'm about to create, the storage I'm about to create, and the compute capacity I'm about to create. So that's a compartment. So I'm going to go here and create the compartment. It's going to be the finance compartment. I'll do that. Now I'm going to go, now that I've created the finance compartment, I'm going to start creating the network, the subnet, the storage, and so on. So first I've got to navigate to the page, the compartment page. I'm going to finance, and you can see right now that there are no networks, no routing tables, no internet gateways. There's no network here at all. So I'm going to create a network. All right, so here I've selected, by hitting yes, 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 and all of this, I've taken all of the defaults. This is the page where if I had wanted to, I could have, rather than taking a bunch of defaults, in other words, letting the system set up my IP addresses, I could have taken the existing range of IP addresses for an existing data center and then mapped them into our virtual data center. The great thing, again, remember, our network is virtual. We can take ranges of IP addresses. We can lift your existing IP addresses and map them onto create a virtual data center with that same range of IP addresses. That means you don't have to touch or retest any of your programs. You leave them intact. You can lift the whole data center up, if you will, and move it over. This is a big deal. It really is a big deal. But in this case, I'm not going to do that. I'm just going to let the system assign a range of IP addresses. In other words, the route tables. I am going to now allow a public access to the internet. And the network is created. Okay, now I got to create a subnet. And by the way, any of you who are network administrators, this is very, very, very familiar lexicon. You create a network. It's very much like creating a physical network in your data center, and then you divide that up into subnets. This is very, very common. So it's kind of, you're doing in the virtual world what you would normally do in the physical world. All right, so here we're creating a subnet. Once again, I'm going to take the system defaults. Over here, I'm going to use the existing routing tables and default security list, and I'm going to locate, again, I could have mapped into my existing IP range. That's a different step. I'm just taking the defaults instead. Here I'm going to put it into an availability domain called US Commercial Central 1A, and I'm going to create this subnet. Now I have got a subnet. You can see the availability domain is USACOM Central 1A. Now I've got a network. Now I've got a network. I need storage. So click on storage. I'm going to create a volume. There's a volume. And here I've given it a name, financial storage. And I'm going to take 1,000 gigabytes of high performance storage. That would be NVMe SSD, non-volatile memory, flash. I'm using flash storage. Okay, I've got flash storage. And next thing so now I've got my storage. Next thing I've got to do, I need compute capacity, so I'm going to go to instances. And I'm going to create an instance. And here I've got to choose my operating system, choose an image. I'll take our current version of Linux version 6.7. I will do 4 Oracle CPUs and 30 gigabytes of main memory. And I will launch. And now we have 1 instance, 4 CPUs, 30 gigs of main memory. We have storage. We have a fully virtualized network. That's about as complicated as it gets. Thank you very much.
Then they got me at 2 hours.
I looked at back like this. He looked back.